4a and b are a little bit of a review of what we did in examples 1 and 2, and then 4c is something new. So again, we have so far dealt with the a value, dealt with the b value, dealt with the c value. The only thing we haven't done is worked with our d value. Okay. I'm going to change the wording instead of the same grid. We're going to do it on separate grids. So off to the side, otherwise things get too busy. Off to the side, we'll start with y equals sine x. So this is your parent graph, so you need to have your parent graph memorized so you can graph it quickly. You take your period of 2 pi, divide it into 4 equal sections, mark your maximum at 1, your minimum at -1. Your sine graph starts in the middle, going up. Okay. You can't do this on a test, but I want our domain to just have arrowheads on the end this time. So I'm going to take off from 0 to 2 pi exactly. Wouldn't that be nice? Don't like a question, just stroke it out, change it. I would rather answer square root of 25. 5. Good. That should be worth 4 marks. So part A, y equals 3 sine x. The shortcut that we're going to do for A is to realize that vertical stretches just change our amplitude. So when I go to graph this, a little bit more space, instead of going from -1 to 1, I'm going to go from 3 to -3. My period is still 2 pi because there's no b value changing my period. A sine graph starts in the middle going up. And now we have an amplitude of 3. So you can already see we're using some shortcuts for drawing sine and cosine. Right? Sine starts in the middle going up. We have those 4 sections. And then you can just go middle, maximum, middle, minimum, middle. And draw your curve through them. Instead of having to do each individual point off to the side, this is a lot faster. Part B. Y equals sine 3x. Now this is a b value. Your b value affects your period. At the bottom, under example 2, we had written the following formula that your period is 2 pi over your b value, which should make sense because this is a horizontal compression. Your x values are getting multiplied by 1/3. If your period was 2 pi and you multiplied it by 1/3, your period would become 2 pi over 3, which is exactly 2 pi divided by your b value. So now when we go to graph this, instead of having 2 pi as our period, we have 2 pi divided by 3. Again, we still break it into 4 equal sections. A little bit of mental math. I always figure out the middle one first, because half of 2 pi over 3 is pi over 3. And once I found the middle one, I always find the next single dash first, because that's going to be half of pi over 3, half of pi over 3, pi over 6. And then, of course, there's one left. That's the one I find next. And I actually use that if each of these are equally spaced, which they're supposed to be, even if my drawing is a little bit off, this is 1 pi over 6. This is 2 pi over 6. This would be 3 pi over 6. Of course, that does reduce, but it's okay if you write it not reduced. I could have reduced 3 pi over 6 to pi over 2. My amplitude is still 1, so my maximum and minimum are still 1 and negative 1. And where does a sine graph start? In the middle, going up to a maximum, back to the middle, down to the minimum, back to the middle. And then finally, in part C, finally we get to the d value where we have a plus 3 afterwards. Now, that plus 3, from translations, we know that that's a vertical translation 3 units up. What in particular is that going to change? That's going to change the sinusoidal axis, or your center line. Sometimes it's called an average. So anytime that we have a d value that moves something 3 up, we're going to have a new place for our sinusoidal axis. And when we go to graph this, notice on all of our graphs up till now, we haven't labeled our sinusoidal axis because it was right on our x-axis. The x-axis kind of was already drawn for us, so it's like kind of redundant to draw a dotted line on top of it because you could see it was the center. But when it gets moved up 3, you're going to take out your red pen, draw a dotted line, label y equals 3 as your sinusoidal axis. Our amplitude is still 1. But our a value, being 1, means that your amplitude goes up 1 from your center line, down 1 from your center line. So we're going to label that our maximum is going to be at 4, and our minimum is going to be at 2. There's no b value, or our b value is 1. Our period's not going to change. So our period will still label as 2 pi and divide into 4 equal sections. And then this language that I've been using all along becomes important. Where does a sine graph start? Okay. And this is where, okay, I'm going to scroll back. Here's our sine graph, right? Sometimes when you ask someone, where does a sine graph start, they say 0. True, but for all of our sine graphs, we're going to start saying it starts on the middle, or on the sinusoidal axis, going up. Because when we get to this example now, where does my sinusoidal graph start? Where does my sine graph start? On my sinusoidal axis, in the middle, going up. And so if it's in the middle going up, at the first tick mark, it's going to be at a maximum. Next tick mark, back to the middle. Next tick mark, down to the minimum. Next tick mark, back. And we've just shifted it up 3 units. But instead of having to add points to each of those things, we can do it really quickly. All right, questions 6 and 7 for practice.